Hi friends, in this session we study about the variance, coefficient of variation and coefficient of standard deviation. The term variance was used to describe the square of the standard deviation by R.A. Fisher in 1913. Mr. Ronald Fisher, born in 1890 and he got that in 1962. The concept of variance is highly important in advanced work where it is possible to split the total into several parts, each attributable to one of the factors causing variation in their original series. Variance is nothing but the square of standard deviation, means sigma square. Both the variance and standard deviation are measures of variability in a population. The smaller the value of variance, the lesser the variability or greater the uniformity in the population. Now I explain you the variance. Variance, we know that it is nothing, it is just we know that variance is equal to square of standard deviation, which means sigma square. It is a absolute measure of dispersion. Now another measure of dispersion is the coefficient of variance, which is the relative measure of dispersion. It is denoted by CV. First I explain you the coefficient of variation. The coefficient of variation, the variation is an absolute measure of dispersion. The corresponding relative measure is known as the coefficient of variation. This measure, developed by Carl Pearson, is the most commonly used measure of relative variation. It is used in such problems where we want to compare the variability of two or more than two series. That series or group for which the coefficient of variation is greater is said to be more variable, or conversely less consistent, less uniform, less stable, or less homogeneous. On the other hand, the series for which coefficient of variation is less is said to be less variable or more consistent, more uniform, more stable, or more homogeneous. The coefficient of variation is denoted by CV and is obtained by as follows. The coefficient of variation is denoted by CV and is obtained by this formula. CV is equal to standard deviation over mean multiplied by 100. So here you see this formula we have written here. CV is equal to sigma over x bar multiplied by 100. The same way, if you have to find out the coefficient of standard deviation, it is also the similar formula, but little bit differences there. It is standard deviation over mean and not multiplied by 100. It is also the relative measure of dispersion. So basically we mostly use the coefficient of variation instead of coefficient of standard deviation. Now I explain you this coefficient of variation and the problems relating to the variability or consistency with the tutor track example. Here is one example. We have goals scored by two teams in a football session were as follows. You see here the number of goals scored in a football match: 0, 1, 2, 3, 4, 5 goals here, and number of football matches played by team A and team B are given here. You see here by team A the number of football matches played: 15, 10, 7, 5, 3, 2. And by team B the number of matches played: 20, 10, 5, 4, 2, 1. And the total number of matches played by both the teams is 42 each. So first of all, this sort of data is given to us, and what we have to find out? So we have to calculate the coefficient of variation and state which team is more consistent. We have to find out the consistency. The consistency, as I explained you, it is measured by the coefficient of variation. If the coefficient of variation is less, then it is more consistent. So first of all, we have to find out the coefficient of variation for team A and team B. For this, 1 minute, you look at this. coefficient of variation CV. CV is equal to sigma over x bar into 100, and sigma is equal to square root of x minus x bar whole square over n. And here we have to find out the x bar, where x bar is equal to summation of x over n. So first of all, we have to find out the x bar. When we get the x bar, we will find out the standard deviation, where we need x bar, the mean. So we calculate the sigma. When we got these two things, sigma and x bar, we put these values in this formula of coefficient of variation, or we could find out the coefficient of variation. So here we have to make the table. For this, look at here. First of all, we have to write down the data whatever we have. We'll write it down here. The serial number I am giving here, the data serial number. So first I write down the serial number of the datas. 1, 2, 3, 4, 5, 6 data we have here, and I write down all the data here. 15, 10, 7. For x, we are taking the value of team A, putting in x. We are assuming the values of the football matches played by team A. 15, 10, 7, 5, 3, 2. So I write down here 15, 10, 7, 5, 3 and 2. And the matches played by team B would assume y. So I will write down here y. So 20, 10, 5, 4, 2, 1. 20, 10, 5, 4, 2, 1. So these are the matches played by team B, and these are the matches played by team A. Now we have to find out the mean for both the team, for mean of x and mean of y. For this, we will get the summation of this, summation of x, and we have a need of summation of y also. So we find out the summation of 15 plus 10, 25, plus 7, 32, plus 5, 37, plus 3, 40, and it is 42 now. This is 42. Just a moment, I change the ink. It is 42. And here you see 20 plus 10, 30, plus 5, 35, 4, 39, and 2, 41, plus 1, 42. Now we find out the mean of x bar and y bar. We have to find out here. So we find out here x bar. X bar is equal to summation of x over n. So I am putting here x bar is equal to summation of x is 42 and the total number of data is 6. So I cut it 6 one time, 6 7 times. So the x bar is equal to 7. We have got this one. X bar we have 7. Now we find out y bar. Y bar, summation of y over n. So summation of x bar is equal to summation of y is 42. We have to put here 42, and the total number of data is 6 here also. So we get the same thing here 7 times. So we get here y bar is also 7. So x bar and y bar we have got here, both are 7 here. So what we have to find out? We have to find out the deviation through mean of this data x. So we get here 15 minus 7. 15 minus 7. which is equal to 8, positive 8, 10 minus 7, which is equal to positive 3, 7 minus 7, which is equal to 0, 5 minus 7, which is equal to negative 2, 3 minus 7, which is equal to negative 4, and 2 minus 7, which is equal to negative 5. So here we have to make the square of this all. We have to make the square of this all. Dx square we have to find out. 8 square is equal to 8 square is equal to 64. 3 square is equal to 9. 0 square is equal to 0. Minus 2 square is equal to 4, positive 4. Minus 4 square is equal to 16. And minus 5 square is equal to 25. So we have got here this all. Now we get the summation of this. So we find out the summation. 4 plus 9, 13, plus 4, 17, and 6, 23, and 5, 28. So we put down here 8, we get to carry. 2 plus 6, 8. 8 plus 1, 9. 9 plus 2, 11. So it is 118 here we have got. We don't have need of this summation of dx because we have the formula x minus x bar whole square over n. So we always get the summation 0 here if we get the any deviation through actual mean. So it is, you see, you can look at here, you can verify it here. 8 plus 3 is equal to 11. Here you calculate minus 5, minus 4, minus 2, it is also 11. So plus 11 minus 11 always 0. You get always here 0. So there is no need to take the summation of dx. Here now we find out dy, deviation of y from mean. So here we know that the y bar is also 7. So we get 20 minus 7, which is positive 13. 10 minus 7, which is positive 3. 5 minus 7, which is negative 2. 4 minus 7, which is negative 3. 2 minus 7, which is negative 5. And 1 minus 7, which is negative 6. So we have got these all. Now we make the square of these all. So we see 13 square, which is 169. 3 square, which is 9. Minus 2 square, which is 4, positive 4. Minus 3 square, which is positive 9. Minus 5 square, which is positive 25. And minus 6 square, which is 36. Now we get the summation of this. 9 plus 9, 18 plus 4, 22 plus 9, 31 plus 5, 36. 36 plus 6, 42. So 2 is here. I change the color. 42. So we put down here 2 and 4 carry. 4 plus 6, 10. 10 plus 2, 12. 12 plus 3, 15. 5 here we are writing down, and 1 carry. 1 plus 1, 2. So it is 252 now we have. So we have got these all summations. Now we know the formula to find out the sigma. It is sigma is equal to square root of summation of a deviation through mean of the data, the square of the summation of deviation through mean of the data over n. So I write down for x and for y. For x, sigma is equal to square root of summation of dx square over n. So we put down here values. Just a moment. Summation of dx square. Summation of dx square is 118, and n we know that it is 6. The total number of data is 6. So dx square 118 over 6. So here we simplify this. 6 one time, 6 one time, now 558. 6 9 times, 54, and 2 remains, 4 remains here. 6 times 36, or 6 times 36, and in this way we get the data. So we got here, just a moment. So we get here square root of 19.666067. So we get here this square root would be 4.43. It is 4.43. So it is the sigma of x we have got here. Standard deviation of x we have got here. Now we have to find out the standard deviation for y. So we get here for y. So I write down sigma y is equal to summation of dy square over n. So here you see summation of dy square is here 252. It is 252. We put it down here 252, and the total number of data is 6. So we get here 252 divided by 6 is 42. Now we get the square root of this 42, which is 6.48. So it is standard deviation of y. So we have got both the standard deviation here. Now finally we have to find out the coefficient of variance. For this, coefficient of variance for x is equal to summation of x over x bar into 100. So we know that the summation of x is 4.43, which is 4.43, and x bar we know that, which is 7 into 100. So we see what happens now. So it is 4.43 into 100. So we get 443 over 7. So 443 divided by 7, we get here 63.2857. Or we could write in this way, if we have to take only 2 numbers after decimal, so we get it 63.29. So this is the CV, coefficient of variation for x. Now we find out the coefficient of variation for y. Now we find out coefficient of variation for y, which is equal to standard deviation of y over mean of y into 100. So we see the standard deviation of y, which is 6.48. We have to put down here 6.48 over, we know the mean of y is same as it is of x in this question. So we see what happens now. So it is 648 over 7. So we get here 648 over 7, which is 92.5714. So we get here 92.57. So this is the coefficient of variation for y. So the question we had, calculate the coefficient of variation and state which team is more consistent. So we have calculate the coefficient of variation for team A and for team B, and we have to explain which team is more consistent. So as I explain you here, look at here, the series or group for which the coefficient of variation is greater is said to be more variable or conversely less consistent. The series which has greater coefficient of variation would be less consistent, less uniform, less stable, or less homogeneous. So more consistency we see on other hand, the series for which coefficient of variance is less is said to be less variable or more consistent. So the series whose coefficient of variation is less would be more consistent. So here you see the coefficient of variation of x is less. Coefficient of variation of x is less coefficient of variation of y. So this team A is more consistent than team Y. So the answer here, the answer team A is more consistent than team B, because the coefficient of variation of team A is 63.29, which is less than the coefficient of variation of team Y, 92.57. So this is a way to find out the coefficient of variation from a given data and find out the consistency and variability of the data. Thank you.